next part of the lesson 27 packet that we want to talk about is how do we approach the second derivative tests from being presented with a graph. In many cases, the graph that we're going to be presented with is going to be an F prime graph. College Board loves to have us looking at F prime graphs. And we've already talked in lesson 26 about how to look at an F prime graph, and from an F prime graph determine where F is increasing, where F is decreasing, where F has a relative minimum, where F has a relative maximum. Looking at an F prime graph to get F double prime information, I'm going to write this down for us to remind us. If we're looking at an F prime graph, F double prime is the slope of an F prime graph. Now, we talked about this before, how I really like a number line. I like to use the same tool both for the problems where I'm presented with a graph and the problems where I'm presented with equations, because the number line tool is just a tool I'm comfortable with. So once again, when I go to my F prime graph, if I think about F double prime, I'm focusing on slope. The two red areas are the two areas on this graph where I have negative slope. So if I were making a number line for this F double prime information, I would look at it and go, looks like I have some negative slope until I get to about here. That lines up with an x of -1. I then have a region with a positive slope. And it looks like I get that positive slope region up to where x is about 2. If I erase kind of my marks here, you can see I think there's a 2. Then you can see we're going to hit here at the 4. So I have my negative slope region until an x of -1. I have my positive slope region until an x of 2. I now have a negative slope region again till 4, and then it goes positive again. So my F prime graph goes downhill, uphill, downhill, uphill. That means my F double prime values are negative, positive, negative, positive. Once I have the number line, I am literally not going to look at this graph anymore. I am going to look at what this says. Because if I look at my graph, I'm going to want to describe what I see there as opposed to what the information on that graph tells me about F, the graph I cannot see. So where is F? Concave up. Okay, F is going to be concave up, and sometimes it helps to do this first. You say, well, F is concave up when F double prime is positive. And then we can answer on, well, where is F double prime positive? Look at my F double prime number line. F double prime is positive on -1 to 2 and on 4 to infinity. F is concave down when F double prime is negative on the intervals from -infinity to -1, union 2 to 4. And then I literally have 3 locations for points of inflection. points of inflection for F are at x equals -1, x equals 2, and x equals 4. It's really hard because you might be looking at this picture and saying, well, I don't see inflection at -1. That's right. You don't see inflection at -1 because you're not looking at F. If we were looking at the F graph, we would see the inflection at -1. What we're seeing is F prime having a minimum, and we're seeing F double prime changing from negative to positive. Okay. Both of those things is what telling us that F is having inflection points at these values. F is concave up on those intervals. F is concave down on those intervals. So the next problem you should do is this problem. Oh, is this say 5 and this say 5? Oh, that says 4 and I called it 5. Okay, well, I apologize. I'll have to change the name of that video. So given that this is an F prime graph, see what you can tell me about F. And this is actually a really good practice for part of what we did in 26 and what we're doing here in 27. In 26, we looked at graphs to give the increasing and decreasing mins and maxes. In 27, we're looking at the graph information for concavity and points of inflection. So I'd suggest right now stopping the video and seeing if you can go through the analysis, looking at F prime graph to determine where F is increasing, determine where F is decreasing, determine where there's any local mins and maxes, and also then see if you can figure out where F has any, what the concavity is like of F in different locations, and where any points of inflection are. So I'd say pause the video now, give that a shot, and then restart it and check your solutions. Okay, I'm going to go ahead and do that. Hopefully you paused and now you're back. I'm going to go on a clean screen so I have enough room. You know me and my big writing. And I am going to first of all look at my F prime graph in terms of positive versus negative Y values. Y values. Positive versus negative. So it looks like I have, starting at 0, because I've got a clear starting point, that F prime is negative until it cuts up to 3. This is negative Y's. And then between 3 and 5, we have positive Y's. And then we've got 2 parts of negative Y's, 1 up to 9, and then 9 to 10. So 5 to 9, 9 to 10, looks like that. So lots of negative Y's, except for the region of F prime that's between 3 and 5. So that tells me F is in fact decreasing from 0 to 3, from 5 to 9, and from 9 to 10. F is increasing from 3 to 5. F has I'm trying to write the word has and relative. F has a relative minimum at x equals 3. F prime changing from a negative value to a positive value. And F has a relative maximum at x equals 5. Because at x equals 5, after we finished increasing, we then start decreasing. So F prime changing from positive to negative. Now, the hard thing about color coding this is the fact that once you color code it, you kind of can't uncolor code it. It's nice for me because I can make multiple copies of the graph and I can do different things. So this is helpful for me for notes. You'll have to kind of think about how you're going to attack this if you only have one graph to look at. When we're looking at the F prime graph, F double prime is the slope. Whew! And so we got a lot of changing slopes here. When I make my F double prime number line, I got a slope change at 1. I got a slope change at 4. I got a slope change at 7. I got a slope change at 9. Right here, right here, right here, right here. The slope of F prime is changing at all of those points. It's technically undefined at 9. And that's okay. That can still be a point of inflection. Okay? It still could be a place where concavity changes. The slope doesn't have to exist at a point to change sign on either side of the point. So let's go ahead and do this. Negative slope, and then a positive slope, and then a negative slope, and then a positive slope, and then a negative slope. Downhill, uphill. Downhill, uphill, downhill. So concave up, F is concave up on 1 to 4, 7 to 9. F double prime positive. F is concave down from 0 to 1, 4 to 7, 9 to 10. F double prime negative. Oops, one more time. Okay, F has POI, point of inflection, points of inflection, at at all those numbers, at x equals 1, 4, 7, and 9. This thing's wiggly. F double prime, changing sign. This is what you're going to need to practice. These are the things that you're going to be practicing on the 26 homework for first derivative, and then 27 homework might have, I haven't looked at it that closely. I know it has second derivative stuff. I'm not sure how much first derivative is mixed in, but ultimately a lot of times we are being asked to do both first and second derivative analysis for a function. Whether we do that starting with an equation or starting from a graph perspective. This is the end of the second video for our lesson 27 packet.